SQLpass.org is the URL. And they offer a lot of different services to the community. They've got, periodically they do 24 hours of pass, which is 24 one-hour sessions that you can attend online. They just had them last week. We've got SQL Saturdays. They've had SQL Saturdays all over the world. We've done 3 of them right here in this building. We are gearing up for our next one, which is probably going to be in March.
By the way, what, the code camp doesn't have any SQL track this year? No past SQL?
Pass did not sponsor, and I have not had the time to step in and help. We've got the Pass Summit coming up, which is a great conference, and also the Pass Business Analytics Conference, which is going to be in Santa Clara in, I guess it's in April.
April?
Yeah.
It was in San Jose a couple of months ago.
We've got past chapters, so we are one of the official past chapters here. They've got a variety of virtual chapters, so the different.
I made one. Did you know?
Which one is it?
In-memory technologies.
Oh, okay, so the new one.
Yeah.
Great. So we've got a few sponsors help us pay the bills. And we've got a couple of upcoming meetings. So at this facility on October 2nd, we've got Sean Mika of Microsoft speaking on the analytics platform system. APS is the new acronym, but this was PDW, Parallel Data Warehouse. It's now APS and adds support for Hadoop on the same appliance. And then Silicon Valley Code Camp, which Amit just mentioned, is on October 11th and 12th. This is a free event, 2 full days of learning. They've got, if you've got kids, they've got programming classes for kids on Sunday. It's at Foothill College. You do need to register for this. They fill up. It's free, easy to find online.
It's awesome if you have it there.
Then November 4th through 7th in Seattle, we've got this year's Pass Summit. It's the largest conference for SQL Server and Microsoft BI professionals worldwide. Over 190 sessions, 5,000 attendees. And there's a code here that will save you $150 if you decide to register. I did get an email from somebody today who told me that the code didn't work. And if you run into that, I don't know what their problem was, but if you use it and you run into it, it doesn't work for you, just email me or give me a call, and I'll figure it out. I need to find out what the
Is it possible they put in those versus?
Oh, they tried both. They said they tried both. Okay. We give people a chance to make an announcement if you're looking for work, if you're trying to hire somebody, if there's a meeting that I haven't mentioned that might be of interest to people in the room, that sort of thing. This is your chance to announce. Any announcements today? Okay. So tonight's speaker, many of you already know. He's a Microsoft SQL Server MVP and mentor at SolidQ. He's also co-leader of this group, Levin. He consults, teaches, speaks around the world on SQL Server, and he has a broad range of expertise around, we're listing 3 things: data modeling, database design, and T-SQL performance, but he also mentioned another that's kind of added to that, which is the in-memory.
In-memory technologies, yeah.
Yep.
Hackathon.
And so, Hackathon, yeah, the product formerly known as Hackathon. And let me just turn things over to Amit.
Okay, thank you very much, Mark. So let me see how So, who here has been to one of the previous sessions that we had about Windows functions? Okay. How many people are intimately familiar with Windows functions? 1, 2.
Someone here.
So how are we going to do it, Mark? What do you suggest? That's the problem when you have a session in multiple sequentials, and then it's not the same people that come. Okay, so I'm going to go and I'm going to try. Today's topic is supposed to be the optimization of window functions. So I'm going to start over there, and if there's anything that is completely obscure, just let me know, and I'll try to revisit some of the window function essentials. So, and I also hope it works on this laptop, because it's pretty much the first time I use it here. So for the demo, I'm going to create a table. You can see here. By the way, do you want me to increase the font?
Yeah, that'd be great.
This is the table that we're going to use for the demo queries. You can see it's just, I took a couple of tables from AdventureWorks and made an order total temporary table, which contains sales order ID, customer ID, order date, salesperson ID, and the total, which is taken from the original order details. Okay, so it's pretty straightforward. You can see the thing is, where the message is, you can show this. You have to go from here. Anyway, don't worry about it. So I guess you can see numeric sales order, numeric customer order date, salesperson, numeric, and total money-wise. I'm going to create what I expect every table to have, which is at least a primary key. That's the sales order ID, and I'm going to leave the cluster index for now, so we're going to have a non-cluster primary key. And let's go, all these things we covered in the previous sessions. So let's go directly to the optimizations. By the way, did we discuss window frame inclusion, filter clause, distinct aggregates, those things? Do you remember? I don't remember if we discussed these or not. So maybe a quick detour before we go into the observation, before we go into the optimization. So the filter clause, as you can see in the query here, SQL Server doesn't really like it, and the reason is that it's not implemented. But standard ANSI allows you to add an additional filter within the partition or the frame for your window function. So I can say, I want to sum all totals, but only for the orders that have a salesperson ID, where it's not null. Okay? That is not supported in SQL Server. However, there's an easy workaround. Can you think of a workaround? Nobody close from? Okay, if I add anything, if I add a word clause to the query, it's going to filter the number of rows that are getting returned. Here, I want to get all the order totals. There's no filter. Okay? I just went for each of the order. I'm going to have an additional column which sums all the orders for that particular customer. But in this case, I'm only looking for orders that were made by a specific salesperson. Or not, by a salesperson, not a specific salesperson, but not without a salesperson. Okay? So not an online order, for example. So the where clause is not going to help you here. Any other ideas?
Subquery. Well, select inside of your select
Subquery.
A subquery within the window function?
No.
Okay, so instead of the window function?
Yes.
How are you going to do that? You're going to do select where customer ID equals customer ID, right? So if you've been here with the previous presentations, you would see that in terms of performance, is going to be a nightmare. Because for each row, it's going to go and scan all the rows for that particular customer every time it encounters them, right? So we still want to be able to do it with a window function. And one of the tricks to do it is as follows. Look at the following query. And ignore the order, right? So instead of saying sum order total, I can sum with a condition and say when the salesperson is not null, then please add the order total, else, which means that the salesperson is null, then sum null. So effectively, although I'm passing all the rows, I'm only summing the order totals for the ones that have the salesperson ID. Okay? And this, of course, is a perfectly legitimate query. You can see all the ones that have, or the ones that don't have a salesperson, and you can see that all those orders have null, and the ones that have that total for that customer. Another thing is the need to allow distinct aggregates. So, for example, look at this query, tell me what it does.
Just use the count of unique customer IDs for every salesperson ID.
Right, I want to return all the rows, and for each salesperson, I want to add a column that tells me how many unique customers that particular salesperson handled. Legitimate question?
Yes.
Yes. Okay. So let's try to run this. And then you get the following error, which tells you that the use of distinct is not allowed with the over clause.
It doesn't complain about it, though, does it?
What, in terms of syntax?
Yeah.
Here, no, the highlighter doesn't.
Yeah.
Okay, so how would you work around that?
Maybe a last function?
Maybe a
Last? Count distinct?
how would you use last for count distinct? Any ideas? Okay, let's think about the set. If I draw the set for a minute here. Remember that I have to. So here is my table source, and I have my order ID, and I have my customer ID, and I have my order date, salesperson ID, and that's it, right? And I want to add another column that will tell me how many customers that particular salesperson ID handled. So let's say order ID is 1, 2, 3, 4, 5, 6. Customer ID is 1, 1, 2, 1, 2, 2. Order date is irrelevant for this query. And the salesperson ID, here I have salesperson ID 1, 2, 1, 1, 2, 1. I have only 2 salespeople and 2 customers, okay? Not a very successful business. So what do you expect to see here?
Much too.
I want the distinct cost per salesperson, right? So what will I get for 1? 2. What will I get for 2? 2 as well, right? That doesn't look very good. So let's do this, 3 and 4. It's not 3 and 3. No, you're confusing. Oh, it was okay.
Was it? Oh, 4, sorry, I apologize.
So now, salesperson 1 has 1, 2, and 4, and salesperson 2 has 1 and 3, right? So I have 3 and 2. 3, 2, 3, 3, 2, 3. One way to go about it would be the easiest thing, and that's pretty much what I drew here. If I can have a subquery that will recalculate the number of distinct customers outside of the function, and then I can join it, that would be one way to do it. But there's another much easier way to do it. If you think about it, if I take the list of customers per salesperson ID. So for salesperson ID 1, I have customers 1, 2, and 4, right? But customer number 1 appears twice. So I have 1, 2, 1, 4, right? What do I want to do? I don't want to count this one. What's unique about this row? By the way, either this row or this row, it doesn't really matter. What's unique about it?
Can you use a
What? Yeah?
Can you use a ranking function in this case to help out? A ranking function?
That's a good idea. What would you do with a ranking function?
So not a dense rank. There's 2 kinds of ranks, isn't there?
There's more than the ranking functions in general. There's 4 of them. There's row number, there's rank, dense rank, and n-type. However, for this, what do you need? If I'm looking to count only the first occurrence of each customer per salesperson ID. So, and I want to continue with your line of thought. What will happen if I add a row number? I'll add another column here, which I'm not going to see, which is going to be a row number, and it's going to be partitioned by customer ID. So this is going to be 1, this is the first occurrence, this is going to be 1, this is going to be 2, because this is the second occurrence of customer 1, and this is going to be 1 again.
So yeah, you can use a rank there too.
So once I have the row number, all I need to do is eliminate all the rows where the row number is larger than 1. And then I guarantee that I'm only going to count those, the distinct customers in this case, right? Okay, so, and by the way, because my function eventually is going to run a count, and the count is an aggregate, and because I don't have a group by, it's going to scan, right, the whole frame here. So, my count, what will I want to do in this case? If this is the first occurrence of a customer, count it. If this is the first occurrence of a customer, count it. If this is a second occurrence of the first customer, what do I want to count?
0.
No.
No.
Yeah. Aggregate functions, it's a count, it's not a sum.
Right.
If I'm going to count 1, 1, 0, 0, that's still going to be 4. Right? Okay? So the only thing that aggregate functions ignore is null, right? So the count is going to be 3, which means 1, 2, 3 unique customers per that particular salesperson ID. So how does it look? Let's start with this case expression. Case row number over partition by salesperson ID and customer ID, order by order date. By the way, is the order by really necessary here? What does the order by mean in this context? What does order by order date mean in this context? What does it do here?
A little bit high. Earliest order first.
What does it determine?
I think it just determines order of evaluation.
That will determine by what I'm going to rank or judge my rows. In this case, when I say order by order date, that means the one with the with the lowest order date is going to get the highest row number, the lowest row number. And as the order dates keep progressing, do I care here, for this purpose, which one I'm going to count?
No.
I don't care what order, right? Okay. So, can I do without the order by?
No, you can't, because then you've got no way to guarantee.
I don't care about guarantee, but you're right, I can't. Syntax-wise, this is going to be a syntax error.
Yeah, because you need
Okay.
to divide it over, right?
So if I'm going to try and run this query, the function row number must have an order close with an order. So I have to add order by order date. The problem is, as we're going to see in a minute when we get to the optimization, that when I ask SQL Server to order by order date, it's going to order by order date, and that means that there's more work involved than I actually need to do.
Are you allowed to order by null? You are not, are you? Will parser allow that?
Window function and next value for functions do not support constants as order by cross expressions. Okay, so you can't do that. But okay, I'll let you in. I'll show you what it means later. But what you can do is you can put parentheses. Say, select null. Not only is that allowed, that actually the optimizer is aware of that, and it won't incur sort.
Right, okay.
Okay, so it will just randomly, as the rows fly in, it will assign row numbers. Okay? So what does this do? This thing, this is the first part of the query. This takes my customer ID, and you can see here that I'm replacing, when the row number is 1, then return the customer ID, else return null. And you can actually see this here, that the first occurrence of customer 1100, the distinct customer is 1100, and all the other occurrences get null. Okay? So now, once I have this column, the query itself is pretty simple. I just do a count on the distinct column instead of on the original column with exactly the same. So now we know that I can do order by. Wow. Select null. And then we're going to get the result that we wanted. Customer ID and the count of the individual salesperson. By the way, nobody shouted here, But if you look closely, there's something that seems to be a little off in this section. Let me hint you. If you look at the original query,
Yep. Don't you need to?
look at the original query.
You need an as for an over, at least with a row by, I'm surprised. There's no alias on the row ID, no number function. Is that allowed? Where?
You have a new column.
Yeah.
No, as
Oh, nice, I missed that, okay, I apologize.
So if you look at this query, what does the partition by stand for?
It's like a grouping for the salesperson.
It's not grouping. Remember, when we're talking about window function,
It's a cluster.
the partition by is more of a filter.
Okay.
It means that the window function will see only the rows that have the same value for the salesperson, just that same salesperson ID.
Okay.
Okay?
That's the scope of the window, essentially.
That's the scope of the window, yeah, because I don't have a frame definition. So if I don't have a frame definition, my partition, the window that I see in terms of partition is the whole window. So here I see the whole window for that particular salesperson ID, and I'm trying to count how many distinct customers it has. And there's a slight difference in what I'm doing here.
You have the salesperson and the customer.
Why?
Because you want the row numbers to be distinct across salesperson and customer,
Exactly.
just salesperson.
Because at this point, I'm not doing the final calculation. I'm only eliminating the second and third and fourth and anything other than the first occurrence of that particular customer per salesperson ID. Therefore, the row numbers have to be assigned per salesperson and customer, and not just salesperson. And then, of course, after that, the function that comes and that does the actual calculation, of course, that's partition by salesperson. Okay?
How could you refactor that using ranks? Or is it?
Well, it really depends on uniqueness. So row number and rank will be the same as long as it's unique. In this case, it's not unique.
Yep.
So rank is not going to help me. If I happen to have multiple rows that have the same smallest value, they're all going to get counted. And that's not what I wanted. I wanted only the first occurrence of a particular customer or salesperson. Okay, the next problem, which is, this is going to look kind of odd, but open your mind a little bit and let it sink in. I try to do it gradually. So here is a query that does total per customer. It's pretty simple, right? Okay. Now I want to add to this query a single column that will tell me what this particular customer's total is out of the grand total of all orders. It's okay, it's okay. I want to add another column here. If somebody wants to walk me through this, I want to take this and say how much is this sum order total out of the grand total. Now all that's left to do is replace the grand total with what's supposed to come there. So how can we do this?
For the customer?
Pardon?
The grand total for the customer?
No, grand total for the
Grand total for all customers. So what would you put here?
Steve?
Any ideas?
Let's see, will you omit like the partition by, and then it will give you.
I want to use yes. So one of the problems with grouped queries is that I can only group one way, right? I can't group the query multiple ways. So once I have group by customer ID, that's it. The window function doesn't see anything but a single row per customer. But the window function originally, so if I were to do sum over everything, sum of something over no window, I will get over nothing means give me everything, all the rows that come out of the group by. In this case, all the totals of the individual customers is the grand total, right? If I group by customer and add them all up, or if I add them all up individually, I'm going to get the same result. Are we on the same page?
Yeah, makes sense.
Okay. So, what I'm asking here is the sum of what? Order total, right? And then I'm going to run this, and I'm going to get an error which tells me column order total is invalid. And select this because it's not contained in either an aggregate function or the group by clause. And if you think about it, this is not the same as this. This is a group function which works based on the grouping of the group by. This is a window function that doesn't care if the underlying query is grouped or not. It sees the entire result set. And when you run the window function over a column, and if I just put star, star, star here, this is the window function. All this is the window function. Don't confuse it. It's not the same as this one. Okay? So what do I need to sum here? I'm looking for the grand total of what?
All the orders.
Total workers.
Yes, but since I don't have, because the query is a group by query, that means that the individual orders are no longer available. What the select list sees, remember query logical processing? Remember the different phases? The select list can only see what comes out after the group by where it happened. Right? Sorry, where group by happens.
So the select sum from, can you nest it?
That's what I'm trying to do. I'm trying to nest an aggregate.
So if you do an unfiltered summation, so sum order total within those parentheses, or select sum. You won't see total orders at that point, will you?
Is that what you meant?
So select sum total from?
Well, it's something.
No, but I mean, it's not, we're trying to isolate it from the group by, right?
Yeah, I'm trying to write a window function. Let me go over it again. This gave me this error. It tells me, listen, I cannot use this column because it's not part of the group by function, and it's not contained within an aggregate. And that's the tricky part. You say, hey, what do you mean it's not contained in an aggregate? I just put a sum in front of it, right? But this sum is part of the window function, not of the group by function.
Could you collect a running total then of order total?
Yes, I can. With window functions, of course.
And then take the.
But that's not what I'm looking for here. So I'm not looking for a running total. I'm looking for the grand total.
Rookie question, can you reference
I gave you the answer in a second.
yeah, you said hash order totals dot total orders. Can you do that?
I'm not sure I follow.
You know, I'm saying column hash order total, the order total is invalid. Can you reference the total orders just about?
No, after the group by, you can only reference the groups, that's it, queries group by.
I mean, like, can you say total orders instead?
Okay, maybe, hold on, maybe it will be clear. Let's do another query. Select customer ID, order total from, this is important. Excuse me for taking a little bit longer. And order,
Got an extra Z in it.
That's what we said.
okay. Is this very clear?
Yep.
Okay. If I want to add the percentage of this on this query for each, not for per customer, but for each order, if I want to know how much it is from the grand total, what would you do? You do order total divided by sum order total over. No, it's a real function, don't forget. Right?
Yeah, looks good.
This looks good, right? And this will actually give me the correct result. So this is the order total, and it's 0.0001% from the grand total. This is exactly the same. The only difference is that this query is not grouped, and this query is grouped. This has a group by, which forces you to do two things. You can only have the columns that are part of the group by definition as expressions in the select list, and any other column must be within an aggregate function. Sum, count, average, min, max. Right? Okay. So if you look at these two queries, what's the difference? There's the group by here. Here, it's not order total because of the group by, now it's sum order total. So instead of order total, now I have sum order total. And instead of this order total, I have this sum order total, which comes because of the group by customer ID. And what's the problem here?
So it's not unique per customer. It's unique per all.
Okay, I told you it's gonna look,
Yeah.
it's gonna look bad,
Yeah.
but that's what you're looking for.
Which is what you're saying.
Maybe.
I'm looking for a window function which will give me a grand total of all the individual sums of order details. Right? The sum of order total is the total per customer. Now I got 1,000 of those. What do I need to do? I want to sum them all up. So I want the sum of the order totals, and then I divide that and get the percentage that I want. Okay?
Stupid
So-
question, is that a function of the number of elements in the group by? If you were to nest further, or is that just, you know, if you had group by customer ID?
You can't have multiple.
Okay, but I mean, is it directly correlated between the number of sums and the number of group bys? Or is it just luck of the draw here that you roll some of the sum?
I'm not sure I told you, you can only nest two levels. You can't
Oh,
nest
okay,
one.
that's what I was asking, okay.
How would you do that? If I want to group this further, I have to encapsulate it within a subquery.
In essence, a subtotal within longer group by string.
Yeah, but that looks odd, right? I'm sure you haven't seen this.
No.
But that's the right way to do it. It can solve you a lot of problems.
Makes sense.
Yes, it does. I think SQL in general does. Okay, so let's get to optimizations a little bit. I want to at least get done with the indexes. So what I'm doing here, I'm creating a table which I'm going to call large order totals, which is basically taking the original table, multiplying it 256 times larger. So now I have 500,000 rows. Again, the distribution is a little bit different, but overall, it's the same data. So I'm going to create a primary key, a cluster primary key, which is typically what I would expect to find in any table before we get into the actual optimizations. So here is my original table. This is called larger order totals. It's got a clustered primary key and sales order ID. That's it. And let's start with the most simple ranking function and see how we can optimize it. And always, when you optimize a query, when you look at the syntax, one of the keys is to try to understand what work you're asking the optimizer to do and how you would have done it, right? If there's certain things that you know about the data that maybe the optimizer doesn't, how would you guide the optimizer or write the query in a way that will reflect the path of thought that you have, or maybe suit the data better. That will be. Let's take a look at this. So, is the query clear? It's the simplest row function, window function, row number, partition by customer ID, order by order total. So I'm basically looking at all the orders and ranking them per customer based on the size of the order. Okay. Now, before I run the query, try to think about what the optimizer needs to do in order to satisfy this query. Remember, the only index that we have right now is on sales order ID. And if you've been to my physical joint operators, I always give the example, there's with the cards. Have you seen that talk? So I tell you, okay, if you come home and you know there's 500,000 cards on the floor and you have to sort them by tomorrow morning, what would you do? Right? You would try to optimize to the max, right? Otherwise you're going to stay up 3 days sorting through those cards. So what's the actual minimal amount of work that I need to do, and how will I help the optimizer make the most efficient plan, the most efficient data processing to come up with the results for this? So as far anything but the window function is pretty, right? There's nothing to it. It's a simple data access. However, when I'm looking for row number over partition by customer ID and order by order total. In order for the optimizer to be able to calculate the row number per customer ID, the rows have to be grouped or sorted by customer ID. Okay, it depends on the operator that I use for the partitioning, right? Remember, it's still sort of filtering. So I'm going to need to be able to take the rows and sort them by customer, and then per each customer, what would help me a lot? So let's say that I have an index. Well, you know what? Let's do it. Why am I talking? So first one will be a little longer because it's caching. Let's take a look at the execution then. Okay. So I got a clustered index scan, scanning the whole table. Remember, the clustered index is on sales order ID, so that's not going to help us. So if you look, and I'm going to go back to it later, there's a property to the scan that says whether it's order or not. In this case, it's false. Okay? There's 500,000 rows coming out of it, which makes sense. And then SQL Server does a sort. And if you look at the properties, it will tell you by what it needs to sort. So this, if If you look here, there's actually 2 sort columns. Why is that? Why does it sort by customer ID and order total? It's called a partition. We partition by customer ID, so it makes sense that we have all the rows lined up based on customer ID, so we can take a chunk, process them, move them on, take the next chunk, process it, move on, right? Okay. But why the order total? Let's look at the query again. In order to be able to assign the numbers in sequence within that partition, right, I need the rows ordered by order total. So if I have them ordered by customer ID and order total, I'm getting somewhere. Okay? I'm getting somewhere. Because now the optimizer has no choice but to do a sort, and as you can see, it's estimated to be 78% of the query just for the sort. How would I eliminate the sort? I'm going to create an index on customer ID and order total. Right? Okay, now I got an index. Let's run the query again. And the optimizer still says I'm not going to use your index. Why? What does my index include? Customer ID and order total. Is there another column in the index?
Salesperson?
No. No. Whenever there's a clustered index, all the non-clustered indexes have the clustering key as a pointer. So in our case, because sales order ID is a clustered index, this index by default has the sales order ID in it as an included column. However, the query asks for more than that. The query wants not only customer ID and order total, it also wants the order date. So if the order date is not part of the index, and SQL is going to scan or seek the index in order to assign the row numbers, after that, it's going to have to go and retrieve the order date for each and every one, like doing a lookup. Since we have 500,000 rows and it's not filtered, that means going through the index and then doing 500,000 lookups. So it's much cheaper just to scan the whole table to begin with. How can we eliminate that? Cover the index. Include the order date. Now, I always like to explicitly include the clustering key. And the reason is, can anybody think why?
Oh.
It's in there anyway. Even if I put it explicitly in it, or if I don't put it explicitly in it, it's good. In this case, it's going to be there. Okay?
Would you have 2 reads and 2 different indexes potentially?
Just for clarity? No, for very good performance reasons. What happens if tomorrow somebody changes the cluster index? Good point. Tomorrow somebody decides that they're going to put GUIDs on there, and they add a column with a GUID and put the clustered index on that. And all of a sudden, the sales order ID is no longer in the index. And your query that used to run just fine 5 minutes ago, all of a sudden takes 3 hours to complete. Right? So let's roll back the transaction and create our index with the order date and the sales order ID. All of a sudden, the sort is gone. And if you look at the cost of the query, and again, this is estimated. I always tell you, don't trust it, but there's not much else we can go by here. But the estimated sub-query cost is 2.1. And if I roll back the index and run the query again, the cost here is 28. So it's about a factor of 10 in terms of cost. And that makes sense, again, just because the sort here took long. By the way, another interesting thing to note is that when I didn't have the index, the cost of the query was over the default threshold for parallelism, which, does anybody remember what is the default threshold for parallelism? 5. By default, when you install a new SQL Server instance, the cost threshold for parallelism is 5. By the way, if you have SQL servers on modern boxes, go and you're not limiting parallelism, go to all your servers and change that number tomorrow morning. So when I go to new customers, I go anywhere from 50 to 150 for the cost threshold. But 5 is not a good number. 5 was good back in the days of SQL Server 7. When CPUs were very, very weak. And a query with a cost of 5 was really expensive. Today, here's a query with a cost of 28. It runs on my laptop in less than 2 seconds. So the defaults have stayed. Highly recommend reinvestigating. Anyway, the problem with the sort is that it's not linear. The complexity of the sort is n times log n, which means that the more rows you have, it's non-linearly more work to perform the sort. So the more work, the more rows, the more benefit you're going to get from the index. Okay, so going back. So if I want to try and find a rule, a guideline, to help me determine what would be the optimal index to help support a windowed function. What did I start with? What was the first column that I needed to index? In this case?
Partition by.
The partition by. So I'm going to put a P. Next. Order by. Put a no. Next. Even when I created an index and the partitioning and the ordering columns, the optimizer still didn't use it. Why? Because it wasn't included, which means it wasn't what? It wasn't covering the query.
It wasn't covering the index.
Okay? So we want the partition, we want the order,
And the covering index.
and then we want the cover. We want the cover so that the optimizer doesn't have to go and do lookups, right? Okay. This is what you need to remember. This is going to serve you well when you optimize your Windows function. POC, partitioning, ordering, and covering. And there's a little nuance to it. Yes.
Does the order of the covering make a difference?
The order of the include this now. Okay. They're not sorted, so. Okay, so let me just create the index again. Same query, what's the difference? Okay. Logically, does this query make a lot of sense logically, by the way?
No.
Why?
Because there's only one partition.
Because there's going to be only one partition. Okay. But is the index going to support this well? Let's check. Now note the difference. Before it was an index scan, and now we switch to an index seek. So that index is going to help me when not only when I'm doing the partition by a specific column, but if I'm also filtering based on that column. Here's the same query, but this time with a different filter. Is the index going to help us?
You have the cluster.
The cluster is on sales order ID.
Oh, sorry.
So the index, I know it's going to help us assign the row numbers, right? Because it's a POC index. Yeah. Right? Okay. What about the where?
It needs to do a scan. It's a scan.
It needs to scan what? What would be ideal? If I'm looking for the rows that belong to salesperson 290, ideally, if I can access those rows only, I'm doing the minimum amount of work, right? Which is desirable, I hope. Will our index support that goal? Well, first of all, it doesn't have salesperson ID in it, so probably not. But let's see what the optimizer comes up with. So if you look at the execution plan and ignore the missing index recommendation, by the way, it's wrong. I'll show you in a minute. It's wrong. But if we look at the properties of the clustered index scan, you can see here that there's a predicate. Unlike the previous query, which had a seek predicate. What's the difference between a predicate and a seek predicate?
Seek, you get early access, right? Once you're done retrieving, you're done. In terms of it reading the index.
Seek means I'm traversing the index structure and I'm going to get exactly to my starting point. I'm going to read how many rows there are, and once I'm going to switch to the next value, I'm going to stop, return the rows. So I haven't touched, except for one row. By the way, there will always be one more row that you have to read to know that the next value is the next one. So if I need to return 4 rows, I'm always going to have to read 5 rows. Okay, but that's not the problem here. Okay, the seek predicate means I'm traversing the index, getting to my start point, and doing the scan from that point on. However, a predicate like we have here means that this is done on the fly. The rows are fetched from the table, loaded into memory. The predicate then checks whether salesperson ID is 290, and if it's not, it discards them. So I'm going to read through the entire table, do a comparison row by row, and only then come up with the rows for salesperson 290. So yes, I eliminated some of the work involved, but I have not accessed only the rows that I was looking for. So how would you go about optimizing this? And by the way, let's just take a look at what the optimizer suggests here. And you can see that it's, look at the index that it suggests. Hold on, let me see if I can. No, this is important because I see people rely on this all the time. It's not really good. So the index that the optimizer suggests is on salesperson ID, which will allow the filter, and includes all the other columns. If I create this index, it is correct that it will allow me to access only the rows for that particular sales order ID, but this index doesn't help me facilitate the window function. It's not a POC index. Okay?
Can you just include the other items of the POC after the...
So here comes the little addition to the POC, which is the F. So if you have a filter and it's an equality filter, which means I can scan the index in order and still get the correct order for customer ID and order total, then, let's see, let's just roll back the previous transaction, create this index. Now, my execution plan is a single access to the table, filtering for, and we can see that in the seek predicates, filtering for seek predicate on salesperson ID equals 290. And remember, the scan is a sorted scan. Therefore, all my rows will get in the order of salesperson ID 290, which is only, this is only what I'm accessing. And then the rows will come in order of customer ID and order total. Okay? So what these next two operators do, the segment and the sequence project. The segment is a kind of a flag. Okay? So it looks at the rows that come in. The first row that comes in, it turns the flag on, and the flag means new group or new customer. It passes that to the sequence, and the sequence assigns the first row number. That flag, after that first row, when the second row comes in, that flag is turned down. And then the sequence project knows to continue incrementing the row number as these rows come. And because they come in the order of order total, which was, remember, the third column in the index after salesperson ID, customer ID, and then we have order total, and the rows are assigned based on order total, which means you can just take the rows as they come, and when each row, just increment the row count by one. Correct? Okay, hold on, let me finish this. All of a sudden, the last row for customer 1 has hit, and the next row that comes is customer 2. The segment operator wakes up again, turns on, tells the sequence, hey, this row is the first row of a new group. What does the sequence do? Reset the numbering back to 1. And this is how you get a row number for a customer. Okay? Okay. Now it's going to get trickier. Now I want for salesperson 290, but only the rows where the total is larger than 1,000. Let's keep the original index for a second. Let's run this query with our existing index and see what happens. So first of all, because this has only a few rows, cost difference is not going to be that big. But what I wanted to show you is now we have two predicates. One of them is the seek, which was used to access the rows that belong to salesperson 290. All those rows were loaded into memory, and then the rows that have an order total which is less than or equal 1,000 will be discarded. So I'm still accessing redundant data, right? Let's say that salesperson 290 had 1,000,000 rows, had a million orders, and only 10 of them over 1,000. So you look at the plan, and you see an index seek, which seems to be, yeah, that's what we're looking for. Index seek is great, right? We're accessing only the rows that we wanted to, when in fact, that is not the case. And again, this is something that I see over and over again. Many times people add, for example, to the query, they always have a default date filter for every query. And if you want to filter it, you put a real date in there. And if you don't want to filter it, you put either 1753 or 9999, right? Where date is smaller than 9999. If I have an index on date, how will that appear in the plan? It will be an index seek. It will be an index seek because I'm seeking for dates that are smaller than 9999. However, this is literally the entire table. So it's exactly the same as a full table scan. So you need to watch carefully, and when you have both a predicate and a seek predicate, you want to make sure that you're filtering on the more selective, and then if there's no way around it, and we'll see, for example, if the predicate, we'll see an example in a minute, but not to see an index seek with one row coming out of it, when in fact under the covers there's 100 million rows getting scanned. Only one eventually answers true, but still in order to get to that one you have to scan them. Okay? So watch it. In this case it doesn't really matter because there's only 3 rows for that salesperson.
In the case of the salesperson ID, would you, if you had multiple salesperson IDs, would you get different behavior with an in and distinct values versus a narrow range?
So it's a little bit more complicated than that, and the reason that I said that the FPOC will work when you have an equality predicate, right? So if I have something like in, let's do 290 and 291, okay? I'll keep this. I'm still running the same as the original query. Yeah, that's the non-clustered index. Now see what happened. It did an index seek. It seeked twice. You see the 2 seeks? One for 290 and one for 291. But for those, it didn't use the remainder of the index. So now we get a sort by customer ID as we did before we had the indexes. And the reason being that you could have customer ID once for salesperson 290 and once for salesperson 291, and you still need them together. So if you don't have them together, there's no way around it. It's going to filter on them, concatenate the results, take it all, and resort it based on customer ID regardless of salesperson name.
So with that, since a lot of times you'll end up with canned stored procedures where you set it as a range, even though we have a narrow range, then you're back to a seek. So if you had salesperson greater than equal to 290, less than equal to 91, that reverted back to a non-equality test and then just a full
No,
seek.
it will still incur the sort. So now the optimizer has to make a decision whether it wants to use the POC index to facilitate the row numbers and scan the whole table, or filter first, right, on salesperson ID and order total, and then either do lookups or something.
No, I was referring to whether it wouldn't use then the seek predicate if the salesperson ID is set as a range. You had an in there before, if you just change
Okay, so that depends too. So if you, okay, so between 290 and 295, my guess is that it will use it. Yes, it does. However, between 2 and 2,950, still does. Oh, but I have the right index. I have the index with this, with the salesperson ID, so of course you can do it. Let's go roll back. Let's create the original one without the salesperson ID. Now we go back to the plus index. Okay? Okay. So yeah, I think we're going to keep something for another meeting. This is fun. So there's a lot more. So if you want more window functions, we can have more. We can have a window function year. We're not far. This is, by the way, Amelia was wrong. This is the third part, not the fourth. Because the last time I lost my voice and we showed the, I think it was the Satya announcement of the APS and what's the next page? Okay, so do you want more of this?
Yeah.
Yeah? Yeah? You like it? Yeah. Okay, cool. So we'll have more.
Can you maybe get some of
Thank you.
these examples by emailing?
Yeah, so give me 1 second. If you want to go, this is the book that you want to buy. That's the developer reference. It's good if you know. They're all the same book. They're all the same.
High performance T-SQL.
Microsoft SQL Server 2012 High Performance T-SQL Using Window Function. By the one and only, my dear friend Itzig.
Who is one of Ami's co-workers,
Yes,
SolidQ.
he's one of the founders.
Another SQL Server MVP. Ami, thank you very much. Appreciate it. Yeah,
Thank you.
sorry about the traffic, everybody. I don't watch